Today's lesson is on solving systems by elimination. So the goal in elimination is to add or subtract two equations together and that is for the purpose of eliminating a variable. So I'm just going to write to eliminate one variable. Because if we can eliminate one, we can solve for the other. Okay, we use elimination when both sets of equations are in standard form. Okay, so first example, I've got 3x plus 2y equals 6, and then 5x minus 2y equals 10. So your first goal is to always look at the coefficients and see if either the coefficients of x or y match up. So in this case, you can see the coefficients on the y match up. So if I add these two equations together, what will happen? The 2y and the negative 2y will eliminate. And then I can add everything up. So 3x plus 5x is 8x equals 6 plus 10 is 16. So I eliminated my y and now I just have the x. Well, I can solve for x by dividing both sides by 8. So x equals 2. Now remember, solving systems, it's two lines that intersect. We're finding the point where they intersect, which means we need the x and the y. So plug your x value back into one of your original equations. I'm just going to choose the top one, that 3x minus 2y equals 6. I'm going to plug that in here. So 3 times 2 minus 2y equals 6. So 6 minus 2y equals 6. If I subtract 6 on both sides, 2y negative 2y equals 0, and then you divide, so y equals 0. So the solution to this system, if you were to graph this line and graph this line, they will intersect at the point 2, 0. Now, separating it into like method 1, method 2. Method 1 is just when you have coefficients that match up. Method 2 is when you do not. So here's an example, 3x minus 7y equals 16, negative 9x plus 5y also equals 16. Okay, so if you look here, the coefficients do not match up. The y's, they also do not match up. So is there an easy way to multiply one of our equations so that we have a matchup? Well, if I look at this 3 and 9, I know that if I multiply 3 times 3, it will be 9, and then my coefficients will match up. But if you multiply one part of the equation, you have to multiply everything. So that top equation, 3 times 3, this now is 9x. And then 7 times 3, that's going to be minus 21y, equals 16 times 3 is 48. So now I don't need that top equation. I've got these next two. And now I can add those two together. And now this time, different from the last one, when you add them, the x values eliminate. It doesn't matter which one eliminates as long as one of them does. So this time we'll solve for y. 5 plus negative 21 is negative 16y equals 16 plus 48 is 64. Divide both sides by negative 16. So y equals negative 4. Okay, so now we have to find the x. And you can plug the y into any of these equations and get the x. So I'll go back up to that original one. 3x minus 7y equals 16. Plug the y in. So 3x minus 7 times negative 4 equals 16. So 3x plus 28 equals 16. Subtract, subtract. So 3x equals negative 12. I'm going to write that up here. So then divide by 3. So x equals negative 4. So these two lines will intersect at the point negative 4, negative 4. Okay, let's do another example before we do a story problem. Here I have negative 4x minus 2y equals 14, and negative 10x plus 7y equals negative 25. Okay, so look for the coefficients. So the x's don't match up, the y's don't match up. Is there a way to multiply? I can't multiply 4 to get to 10 or multiply 2 by something to get to 7. So here's an example where we have to multiply both equations. So you've got some options. I like to match up my y's and solve for x first, but it doesn't matter. In this case, what we can do is the 2 in this equation, if I multiply here, and then the 7 in this equation multiply up here, it will guarantee that my y's will match up. So multiply everything in your equation. So the top one, everything by 7. So negative 28x minus 14y equals 14 times 7 is 98. And then the next equation, multiply everything by 2. So negative 20x plus 14y equals negative 50. All right, so that multiplication matched these up. Now I can add, and they will eliminate. So negative 28 plus negative 20 is negative 48x. 98 plus negative 50 is also 48. So x equals negative 1. All right, we have to plug negative 1 back in for any of these equations to find y, and it could be any of these 4. I'll just use that first one. So negative 4x minus 2y equals 14, but I'm plugging in negative 1 here. So negative 1, or negative 4 times negative 1 minus 2y equals 14. So 4 minus 2y equals 14. Subtract 4. So negative 2y equals 10. So y equals negative 5. So they intersect at the point negative 1, negative 5. Okay, here's our last question. At an ice cream parlor, ice cream costs $1.10. I think that's supposed to say ice cream cones, maybe. Cost $1.10, and sundaes cost $2.35. One day, the receipts for a total of, 172 cones and sundaes were $294.20. How many cones were sold? Okay, so we have to write two equations. And if you look at this 172, that was all of the cones. Let's make cones x and sundaes y. All of the cones plus all of the sundaes equals 172. And now an equation that involves all the money. So $1.10 cones plus $2.35 sundaes, to a total of $294.20. So there are my two equations, and now let's solve. All right, so I need my coefficients to match up. Let's say I want my y's to match up. So I can multiply everything here by 235. So 235x plus 235y. So that's coming from me multiplying here and here. And I have to multiply here. 172 times 235 is 404.2. So now I don't need that equation. And now, different from these other equations I've been doing, I've been adding the equations together. Well, in this case, if they're both positive, I'm going to subtract the two equations together, because subtracting is what will make those eliminate. So $1.10 minus 235 is negative 1.25. X equals 294.20 minus 404.20 is negative 110. So now I can solve for x. Divided by 1.25. And we should get that x equals 88. And x represented cones. How many cones were sold? Well, there we go. There's our answer. And if the question up here was Sundays, we would just need to solve for y. So there's your full video on solving systems by elimination. Good luck with your lesson.